Electromagnetic waves are transverse waves. We know this because they can be polarized. They are not a separate form of waves. They exist within the transverse wave family, but they are the most important example of waves you'll ever study. Electromagnetic waves are formed from a combination of a material's electric and magnetic fields. Unlike other waves, they do not need an external medium to move. Electromagnetic waves take their mediums with them. They are extremely special types of wave, as they communicate the electromagnetic force between subatomic particles, and they limit the maximum speed that an object can attain relative to another object in the universe. In short, electromagnetic waves are all forms of light. An electron moving in a magnetic field generates an electromagnetic wave. We use these waves to generate our electricity and to communicate over large distances. Radio waves are the lowest frequency of electromagnetic waves, travelling through vast distances in space and allowing us to communicate with people around the other side of the planet. In the middle is a very narrow band of frequencies that human beings can detect with our eyes. We have built devices that allow us to detect every form of electromagnetic wave or radiation, but these devices only translate the frequencies and wavelengths of the invisible electromagnetic wave into visible wavelengths we can see. At the other end of the spectrum is gamma radiation. Even though we sometimes treat this as a particle, gamma rays are a wave. They are extremely energetic as they vibrate extremely quickly. They have a very low wavelength, smaller than the width of an atom, and a very high frequency. We can discuss these electromagnetic waves as particles called photons in certain circumstances to make discussions easier, but this is a discussion we have already had when we talked about fundamental particles. As a wave, electromagnetic radiation can be used in many ways. The most trivial is by exploiting their property of polarization to reduce glare from objects in Polaroid sunglasses. Sunlight is reflected off the ground and all objects at random. When the sun is bright, this can cause large amounts of light to enter the eye and create a painful and distracting situation where an object blinds you temporarily due to its reflected light. By wearing Polaroid sunglasses, you reduce the amount of light entering your eye, so that is oriented with your sunglasses. If your sunglasses are oriented vertically, then you'll only see vertical beams of light. This means that the light reflected directly from the sun will not enter your eyes, as this is reflected horizontally off the ground. The sun is the most intense source of light, so you have reduced the light input to your eye to only allow light scattered from other surfaces, which is far lower. A slightly less trivial use of polarization is in the communication of people using radio or television. Radio waves and microwaves can be polarized. They can also be used to communicate with other people at a distance. If an emitter of these types of radiation produces waves in one orientation, say horizontal, then only people with a horizontal detector can receive this signal. The vertical receiver will not detect enough of the signal to make a pattern. This is what happens in television and mobile phone communication. Transmitters transmit their signals at different orientations to avoid interference of the signal. In this way, you can have two or more signals sharing the same area of space and the same frequency of wave, but they will not interfere with each other and not degrade either signal. This means you can have much bigger areas where people can receive a mobile or radio signal from the same transmitter mast, and so reduce the number of transmitter masts overall.